Analysis of high-rise building and its behavior due to shear wall at different location and in different seismic zones. India 1 at 1 present 1 is 1 fast 1 growing 1 economy 1 and population 1 growth will 1 increase 1 demands 1 of 1 land. 1 to 1 construct 1 high 1 rise 1 structure 1 R 1 more advantage 1 to 1 provide 1 day 1 demands 1 in 1 construction 1 industry. After 1 many practical 1 studies 1 at 1 has shown that use 1 of 1 lateral 1 load resisting systems 1 in the building 1 configuration 1 has 1 tremendously improved 1 the 1 performance 1 of the structure in 1 earthquake. Framed and shear 1 walls are 1 mainly 1 flexural members and 1 usually provided in high 1 rise 1 buildings 1 to 1 avoid the 1 total collapse 1 of 1 the high 1 rise 1 buildings 1 under 1 seismic 1 forces. 1 shear 1 walls 1 are 1 provided 1 in 1 elevator author's name /s per core, face and corner of 1 the 1 structure 1 to increase the stiffens and behavior 1 of structure, thereby resisting 1 the horizontal and vertical 1 forces effectively. In 1 the present study, analysis of RCC1 building has been 1 carried out by changing 1 the locations of 1 shear walls in the 1 building. Also, the effect of variations 1 in seismic zones as per 1 IS codes has 1 been presented. The seismic 1 analysis performed is dynamic 1 response spectrum method as per 1 IS 1893-2016 using the well-known analysis and 1 design software ATABS 15.0. Seismic 1 performance of the building has been 1 investigated based on parameters 1 such as time 1 period, story displacements, story drift and base shear along 1 both the direction 1 of the structure. From the investigation 1 conclude the shear wall 1 impacts in high-rise 1 structural system with 1 respective all seismic 1 zones. Keyword seismic, ATABS, story, Indian standard, high-rise. Introduction. India 1 at 1 present 1 is 1 fast 1 growing 1 economy which 1 brings 1 about 1 demands 1 in 1 increase of 1 infrastructure 1 facilities along 1 with 1 the 2 growth 2 of population. The 2 demand 2 of 2 land in 3 urban 3 regions is increasing 1 day of biate. At 1 ISA imperative 1 that 2 land 3 available 4 for farming 2 and agriculture remains 1 intact. 801 cater the land 2 demand 2 in these regions, vertical development is the 2 only option. This type of development 2 brings challenges to counteract additional 2 lateral loads due to wind and 2 earthquake. This demands 2 changes in the current 2 structural system which needs to be 2 implemented to resist these 2 forces. Much research 2 has been carried which describes 2 the suitability of various lateral load resisting system 2 against deformation and shear exerted due to the 2 earthquake and wind forces. 3. The 2 seismic movement of the ground causes the 2 structure to vibrate and 2 causes structural 2 deformity in the building. Different 2 parameters regarding this deformity 2 like frequency of vibration, time 2 period, and 2 amplitude are of significant importance and defines the overall response of the structure. This overall response 2 also depends on the distribution of seismic 2 forces within the structure which 2 again depends on the 2 method which 2 is used to calculate this 2 distribution. Different methods 2 of 3-dimensional dynamic 2 analysis of structures have become 2 more efficient in use along 2 with the development 2 of 2 technology. Major structural systems. Rigid frame system. Consists 2 of column and girders 2 joined by moment-resistant 2 connections. The lateral stiffness 2 of a rigid frame bent depends 2 on the bending stiffness of the 2 columns, girders, and 2 connections in the plane of the 2 bent. Rigid frame with shear wall. It is 2 a vertical 2 continuous stiffening 2 element, that deform in bending 2 mode. It is used 2 in reinforced concrete 2 buildings and suited 2 to residential buildings 2 and hotels. When shear 2 walls are combined with rigid frame the 2 walls, which tend to 2 deflect in flexural 2 configuration, and the frames, which 2 tend to deflect in shear 2 mode are constrained to adopt a 2 common deflected shape by the horizontal 2 rigidity of the girders and 2 slabs. Consequences, the walls and 2 frames interact 2 horizontally, especially at the top to produce 2 a stiffer and stronger 2 structure. The interacting 2 wall frame combination is appropriate 2 for building in the 20 to 40 stories 2 range, well beyond that of rigid 2 frames or shear walls 2 alone. Shear wall 2 with opening. Frame 2 structures with shear walls are frequently 2 adopted as the structural 2 system for high-rise 2 buildings. The openings may be 2 window, door types openings as 2 described previously. The 2 behavior of wall will change. These 2 change will occur in 2 deflection, bending 2 moment, shear 2 force, and the 2 stress in walls. Openings 2 may be small or large depending 2 on the function of the building. In 2 residential building, opening like 2 window, door, and 2 corridor are sufficient whereas 2 for special building 2 like cinema theaters, function 2 hall, hotels, community halls, it requires 2 larger openings 2 to meet the requirements. Outrigger system. Outriggers 2 are connected directly to the core and to exterior 2 columns. Used in 2 reinforced concrete and steel 2 buildings. Outriggers restrain the 2 rotation of the core and 2 convert part of the 2 moment in the core into a vertical 2 couple at the columns. The two outrigger structural systems not too only proficient in controlling the top two displacements but also play substantial two role in reducing the inter-story two drifts. The two beneficial action is a two function of two factors. The stiffness of the two outrigger varies inversely with 2 the outrigger 2 distance from the 2 base. 2 its 2 location in the 2 building. It provides 2 adequate 2 strength to resist large lateral loads 2 without excessive additional cost. It provides adequate 2 stiffness to resist lateral 2 displacement within 2 permissible limits, thus 2 reducing risk of non-structural 2 damage. They should be 2 located such a way that 2 they also act as functional 2 walls and do not interfere 2 with the architectural 2 of the building. Shear wall 2 should be placed along both 2 the axis, so that lateral 2 stiffness can be provided in both 2 directions, particularly 2 in the case of square 2 buildings. To avoid torsion 2 effect shear wall should be 2 placed symmetrically 2 about the axis. Providing 2 lateral strength to building, shear 3 wall must provide lateral 3 shear strength to the 3 building to resist the horizontal 3 earthquake forces, wind 3 forces, and transfer these 3 forces to the foundation. Providing lateral 3 stiffness to building, shear 3 walls provide large stiffness 3 to building in the 3 direction of their orientation, which 3 reduces lateral sway 3 of the building 3 and thus reduces 3 damage to 3 structure. Role of shear 2 wall. To resist these lateral 2 forces, shear walls are specially 2 designed structural walls 2 included in the buildings to resist 2 horizontal forces that are 2 induced in the plane of the 2 wall due to wind, earthquake 2 and other forces. Advantages of 2 shear wall. Function of shear 2 wall. The main 2 function of a shear wall 2 can be described as 2 follows. Structural 3 analysis methods to understand 3 the behavior 3 of structure. Few of the methods 3 are explained below. Equivalent static method. This approach defines a series 3 of forces acting on a building 3 to represent the effect 3 of earthquake ground motion. It assumes that the building 3 responds in its 3 fundamental mode. For this 3 to be true, the building 3 must be low rise and must 3 not twist 3 significantly when the ground 3 moves. As 3 per this method first the 3 design base shear shall 3 be computed 3 for the building as a 3 whole. Then the 3 base shear shall be 3 distributed to the various 3 floor levels at the corresponding 3 center of mass and finally 3 the design 3 seismic force 3 shall be distributed to individual 3 lateral load resisting elements 3 through 3 structural analysis considering 3 the floor diaphragm action. This 3 method is applicable for 3 regular building with 3 height less than 15 m in seismic 3 zone 2 as per IS 3 code 1893 to 2016. Response 3 spectrum 3 method. The response 3 spectrum represents an envelope 3 of upper bound 3 responses, based on several 3 different ground motion 3 records. For the purpose of 3 seismic analysis, the 3 design spectrum 3 given in IS 1893-2016 is used. This spectrum 3 is based on strong 3 motion records of 8 Indian 3 earthquakes. This method 3 is an elastic dynamic 3 analysis approach 3 that relies on the 3 assumption that dynamic 3 response of the structure 3 may be found by 3 considering the independent 3 response of each natural 3 mode of vibration 3 and then combining 3 the response of each in same 3 way. This is advantageous 3 in the fact that generally 3 only few of the lowest modes of 3 vibration have significance while 3 calculating moments, shear 3 and deflections 3 at different levels of the 3 building. Dynamic 3 analysis. Static 3 analysis method requires less 3 effort because except for the 3 fundamental period, the periods 3 and shapes of higher natural modes 3 of vibration are not 3 considered while in dynamic 3 analysis the periods and shapes of 3 higher natural modes of 3 vibration are also considered 3 addition to fundamental 3 periods which are considered 3 in static 3 analysis. Dynamic 3 method as compared to 3 static method mainly observed 3 base shear is less 3 in static than 3 dynamic the displacement 3 will be less in dynamic 3 and also the moment 3 hence dynamic 3 method is used for 3 analysis. Main objectives. 1 to determine the 3 optimum 3 position of shear wall by consider 3 architectural plan of the 3 building. 2 to 3 analyze behavior of structure 3 due to dynamic load 3 with all seismic 3 zones. 3 to 3 study the structures with respect 3 to story drift ratio, story 3 displacement, time period, base 3 shear and forces. 4 the present 3 study is limited to analysis 3 of 20 story of RCC buildings. 5 to provide guide 3 lines for structural engineer 3 on the serviceability and 3 economic aspects, that 3 could be obtained by using 3 shear wall. Scope of the 3 present work. 1 in the 3 present work 4 structural 3 system has been 3 considered i.e., 1 RCC frame 3 structure without 3 shear wall and 3 structure 3 with 3 shear wall. 2 all 3 models were analyzed 3 using an dynamic response 3 spectrum method as per IS 1893-2016 specifications 3 using ATAB software. 3. Methodology. The term 6 building in civil 6 engineering is used 6 to mean a structure 6 having various components 6 like foundation, walls, columns, floors, roofs, doors, windows, ventilators, stairs lifts, various types of surface finishes etc. Structural 6 analysis and design is used to produce a 6 structure 6 capable of resisting 6 all applied load 6 without 6 failure 6 during its intended 6 life. Prior to 6 the analysis and design 6 of any structure, necessary 6 information regarding supporting 6 soil has to be collected 6 by means of geotechnical 6 investigation. A geotechnical 6 site investigation is the process 6 of collecting information and 6 evaluating the conditions of the site for 6 the purpose of designing and 6 constructing the 6 foundation for a structure. Structural 6 engineers are facing the challenges 6 of striving for most efficient and 6 economical design with 6 accuracy in solution 6 while ensuring that the 6 final design of a 6 building and the building 6 must be serviceable for its intended 6 function over its design 6 lifetime. Nowadays various 6 software packages are available 6 in market for analyzing 6 and designing practically 6 all types of 6 structures viz. RISA, STAAD Pro, ATABS, Strudel, Midas, SAP and RAM etc. Modeling and analysis. Modeling 8 allows planners, designers 8 and engineers to 8 redesign routes 8 based on value engineering 8 principles and changing 8 construction 8 techniques. Modeling 8 and analysis of 8 building is 8 necessary for various 8 components of structure with 8 cost-efficient bridge to 8 overcome all type of 8 disasters, to develop 8 some design which 8 is most efficient in a way 8 to carry high 8 loads at a very 8 low fabrication 8 cost etc. There are 8 many modeling and 8 design softwares are available 8 in construction 8 field. In this 8 research work 8 auto CAD, ATABS, MS8 Office are effectively 8 utilized. Graph 1 time period. According 9 to IS 1893 to 2016 the 9 total number 9 of modes to be considered 9 in the analysis 9 should satisfy the condition 9 that the sum 9 of the modal 9 mass of all 9 the modes selected 9 is 90% the seismic 9 mass. 16 9 modes are considered 9 for the 9 analysis 9 and sum 9 of modal 9 mass of all 9 modes found 9 to be greater 9 than 90% of the 9 total 9 seismic mass. The 9 maximum time period 9 obtained is 1.658 SEC for 9 model -1. The 9 time period 9 is 0.274, 0.917, 91.1239 seconds 9 for model 2, 9 model 3, 9 model 49 respectively, which is 9 lesser than 9 model 1. Whereas, the 9 least time 9 period obtained 9 is 0.274 SEC 9 for model 29 compared 9 to all the 9 other models 9 indicating 9 that it is 9 stiffer 9 model 9 than other 9 models. Base 9 shear 9. T. With 5 the increase 5 in the zones 5 the base shear 5 values is also 5 found to 5 be incrementing 5 and is found 5 to be highest 5 in zones 5. Base 5 shear is 5 highest in 5 model 2 for 5 all the 5 zones. Base 5 shear 5 is found 5 to be least 5 in model 3 and 5 model 1 for 5 all zones along 5 both 5 the directions. The 5% 5 reduction in base 5 shear with 5 respect 5 to model 25 is 519.55% 519.2%, 528.25% along 5x direction, 5 similarly 29.59%, 26.49%, 41.96% 5 along y5 direction 5 for 5 model 1, 5 model 3, 5 model 45 respectively 5 in zone 5b.